Welcome to this CNCF webinar. My name is Viktor Gamov, and today we're going to spend some time to learning about technology that's super exciting for me, and hopefully you also a little bit excited about this technology called Service Mesh. Today's presentation is about a zero-day Service Mesh. What does it mean? What you need to know at the first day when you're starting onboarding with Service Mesh. I'm going to be talking about the origins of the Service Mesh. I'm going to be talking about what kind of problems we're solving there. And you will see the demo. And I will be talking about some of the things that is applicable for specific technology. It used to be so simple. People say, oh, those days when everything was super simple and we didn't have all these distributed technologies, we didn't have all this Kubernetes and all these kind of things. Everything was much easier. We have a one servlet container, or maybe it was application server. We pack everything in one WAR file, or if you not super lucky, it was a YAR file that will include all the components of this application. And after that, you need to connect to some database and just, run with it. But if you think about this, let's take a look on this architecture for a second and think about this, that this actually already was multiple components and multiple things that might go wrong. Things around connecting this application server to database. If many of you remember the times where your application server will provide you with some sort of like a service discovery known as JNDI, Java naming and directory interface, that allows you to calling API of application server to get a location of your database, like a rudimentary discovery service. You can say, oh, give me my production database. And after that, this service will return you URL, will return you connection string that you can apply and connect to your database. And when you need to, call with your database, if you need to work with this database and you need to communicate with all these things, you need to figure out how to work with this efficiently. New times have come, so we can change everything and refactor our systems to microservices. And this is the time where we need to reinvent some of the patterns or maybe re-implement some of the code. And today we're going to be talking about how we can do this like less painful and hopefully will be more efficient. My name is Viktor Gamov. Once again, I am a developer advocate at Kong. At Kong, I am talking to developers, talking about the things that we develop at Kong, dealing with some of the problems some of our users in the community have. And also I do all sorts of things around kind of educating people about the technologies and cloud connectivity and all things around APIs. I also do some of the live streams on the Kong YouTube channel. If you're interested in this type of jazz, don't hesitate, subscribe to that channel, and I will be sharing some of the content there. So when we're talking about the microservices revolution or evolution, we usually like to remember the famous email from Jeff Bezos when he was talking about all the systems need to start talking to each other through APIs. Shouldn't be no other integrations points, and which was a good thing. It's a nice thing to have APIs and how we can use those APIs to connect to the systems. But one of the biggest driver from perspective of operational complexity and like reducing operational complexity was introduction of the containers. One of the technologies that drive this microservices and cloud native revolution. But people still were doing the things even before the containers, right? The things that I mentioned in the very beginning, like WAR files and YAR files. You also kind of sort of package this in some of the standard the format, but it only was standard for certain platforms. With Docker from operational complexity or containers from operational complexity have solved us this idea of transitioned us from build once, run everywhere to the package once, run everywhere. And around 2016, 2017, those ideas that was promoted by big tech in the cloud industry, or like web scale, start kind of like a migrate into the world of the normal people, normal enterprises, traditionally monolithic systems, because the companies decide to go faster with their digital approach to the business and the solving the problems much faster. So let's get back to my application. So let me talk a little bit about how we talk about this in the sense of the modern components. So think about this. The communication between databases, you never deploy database on the same server as your application. You always have it on a separate thing, and maybe even separate team manages this for you. It provides different restrictions, passwords, access control to those databases. So all these things not running together. So they always communicating through the network. So even though we're talking about monolithic application. So with this example of this monolithic application, of this Java EE application server, the communication is happening through TCP channel. The bidirectional streaming and communication is possible between systems, but still at the network. Network communication can be unreliable, can be unsecured. Someone can, interject in between and do something with your traffic. So once we kind of scale this up, like one of the service might calling another service, and the challenges of scaling those technologies becoming unreal. Once we start this decoupling of this monolithic application into the smaller pieces, those pieces still need to communicate to each other somehow through APIs. Let me give you an example of how the things are changed from perspective of how it was before when we have everything in one place. Like, for example, here I'm looking into the interface of this system where one component talks to another component through calling and do something method of this. We're replacing communication between those two services by wrapping all this logic around. So technologies like remote procedure calls, like RMI was very popular in Java, this DCOM technology, and more modern technologies that also evolved from those things. We moved from computation based on CPU, when everything runs as a one single process. We move computation to the network. Now our network is our computer. Like, one service will call another service through API, through certain protocols, and it would also very similar to the things what you've done in the past with calling interface of the object. With this network problem, with the introduction of the network communication, we also start seeing not the problems, but the challenges that you need to solve. You need to solve many things that were given for you for free. For example, process isolation was given since you're running this as in the one sandbox, and all the components needs to run within Security Manager or whatnot. And if you want to do logging, you do logging in the console, and after that you can scrap this using tools like grep, AWK, and some other things. Or you can use like modern stack and consume those files using Filebeats and ship it to Elastic. But there was no centralized place where you can do all this logging, all this tracing, and all these things around the things that you need to do. What you start doing, you maybe start introducing some of those components as application-based libraries. If you need to implement observability, you drop some of the library like Java agent or any other agent that will listening what happens in your system and ship this observability data to some APM, application performance monitoring tool, and after that you kind of analyze it. So you introduce this as a part infrastructure, as a part of your application code. So you start linking some of the infrastructure code inside your application. Sometimes it's good, sometimes it's bad, but things getting much more complex if you trying to introduce more languages. So you trying to be more diverse and hire more talent regardless of the platform, and you want to build the services in the different languages, and which is totally fine because you're now talking through the APIs. It really doesn't matter what kind of implementation language you use. So with this particular approach, now you need to make sure that the framework that you use in one language gives additional or a similar level of functionality in a framework that you use in another language. So that's another problem where you start introducing infrastructure into your application code. So all these things becoming the part of your application, which is a good thing. You're trying to make connection to say external data source resilient. The introduction of the connections pools that will handle retries, that will handle connection pooling and reuse of the connection, maybe logging of these other things. those pieces are part of your architecture now. But many applications might, fail on this recovery or not providing meaningful log just simply because the library in one language or library that use one application will not have the same functionality that has another one. So we need to have the consistent ways to look into our application performance. And those applications, there will be tons of different applications, and the communication and the different functionalities that we will put in there also will have different and distinct things. I didn't even start talking about fragmentations from perspective of how we secure those connections. Security is also, when we start moving into the cloud-based environments, the connectivity security is important. Data in motion security is important. Because you're not running on your infrastructure where you can make sure that everything that you have is kind of like a super secure. So, and with security and reliability in mind, all this and reusability of the components, all these things becoming a nightmare for developers and becoming nightmares for IT departments as well. More like a guerrilla or like a hacking approach would be kind of introduction of this like a shadow IT element. So some of the team members would decide to, or some of the groups and application, they implement the stuff for themselves. So they will make sure that their system is not compromised. However, they might not for 100% following whatever requirements available in organization, because those requirements simply cannot allow them to move faster. And this is going to be more human problem rather than technology problem, where the different teams and different the goals and different the targets are competing instead of building one thing that will be serving one greater good. And those duplication fragmentation brings us to the point where what we will like to do with this deduplication and fragmentation, we'd like to start decoupling this thing. So what about we start moving those pieces of functionality to something that would be part of infrastructure? And in this case, there should be some of the components that you can closely talk, and this component will be solving all of the problems. You can talk to them through the API. You're not talking to some of the library that exists in only particular language, and how you can solve this deduplication. So let's see how it can be done. So with the idea of outsourcing or moving some of the logic around error handling, retry, security, logging, tracing, all these kind of things into separate process and talk to this process through sets of API. So your application will always be talking to outside world, not through the direct communication to the service, but through the proxy. That will be also providing the ways how you can do service discovery, how you will figure out where this data is, and so far and so on. So let's talk a little bit closely about this proxy, how this will work. So each service now will have its own small proxy that the footprint would be negligible comparing to benefits that this proxy provides. So in this case, this proxy will be handling all communication between the services in running a little bit in front of the gun. This particular pattern, when you talking to, or someone will handle the communication between the systems, will be calling a sidecar that all this communication. All communication of the service will be going through this sidecar proxy. And the service will be always talking to proxy through localhost. And in this case, there would be no network communication. And all these problems with retries or circuit breakers and all these kind of things will be handled on the proxy side. So for the service, it would be transparent. Each element or each service or each application will have its own this sidecar that will be running on the local host of the service. In some of the deployment strategies, for example, we here talking mostly about Kubernetes, it can be run together with your application as a part of the sidecar. inside one pod. In deployments that like imagine like VM deployment or deployment in a bare metal, it just simply would be another process that runs internally and will have all the traffic would be routed through this process. So those things can be done, and those things can be implemented through this. So that's why we have this name of the mesh. So communication not happening directly between the services, but rather the proxies. So essentially, proxies are establish our communication and establish our mesh. So, and this pattern also works in your past. Like it also works with the legacy or monolithical application, where you have one component that will be just service mesh, or the proxy will be handling all this communication between different components of the system. Now we need to figure out, we figure out the mechanics between the traffic management, but the next thing that we need to figure out is how to provide those configurations. So definitely those configurations can be, you need to deploy this in a different environments. Like in this particular case, we can deploy this in an environment where we have only virtual machines, or we have the Kubernetes cluster, or we have like bare metal machines. But definitely some of the things around how these things will be handled from perspective of communicating, or from perspective of configuring the services, needs to be solved as well. Since we starting putting all these proxies in one place next to our applications, and the number of applications will grow, we might have a situation where we cannot go and configure their service like manually, or like having static configuration. So that's why we need to come up with some other approach. And this is where another element of service mesh comes into play. Now, we can propagate this communication, those configurations to each service, but it's all about automation. We need to have a suitable automation in order to propagate those configurations. So with the concept of the service mesh, each individual component or each individual application that will be part of this mesh will have its own, we call it data plane. So those proxy also named as a data plane. And there will be some config server that will be also connected to those data planes. And this is the benefit between this, because we already established in a few slides before that communication between the systems only happens through this proxy. So there will be no third party, and this communication service will use some sort of back channel or configuration service will be using some back channel to send this data into this data plane. So this configuration service we will be calling a control plane, and our proxy servers that would be running based on this control plane will be called data planes. So the control plane will have up-to-date information, and it will replicate this configuration to all data planes. So, but those data planes will continue to operate even in a situation when they lose control to control plane, when they lose the connection to control plane. And when the connection will be reestablished, control plane will ship latest and greatest configuration back to data planes. And that's pretty much it about the service mesh. This is how this pattern works. Your application, your service, your piece of functionality that will be exposing either to end user or to another service to consume will communicate through the network, through data plane that will be like a proxy server that will be handling traffic. And there will be somewhere deployed another component that's called control plane that will be responsible for shipping the configuration to all data planes. You can have dynamic reconfiguration of your network connectivity between the services by simply applying the configuration of control plane, and control plane will handle the rest of the stuff to update this configuration, and all these data planes will reconfigure this network. This is exactly how it looked like from perspective of, this is the bigger picture. Each service will have its own data plane, and the control plane will be running this configuration. And this configuration also works at scale, where we need to have communication between different components that runs not only inside one cluster or like one data center. They may running across some wide area network, and with same pattern, but like put this into like is a different gears. You can establish connectivity and provide transparent and seamless integration between components that runs in one data centers or one region or one in one availability zone to another that would be running in different region or even continent or even different cluster. We can have one applications runs inside the Kubernetes, another one runs on the bare metal and service mesh, and those like data planes will allow to connect this and unify those networks and unify the communication between the systems. So let's start putting things into perspective. So with invention of this very lightweight and super performant and most importantly API-rich system called Envoy, it actually also gives a huge boost to development of many like service meshes. Kuma, for example, is a control plane that uses Envoy, data planes in order to configure and implement this service mesh. So Kuma, available in kuma.io. You can find the documentation there. We're going to talk about this in a second. And Envoy is also a CNCF project that is actively developed, and it has a very small footprint that very negligible compared to the benefits that it provides from perspective of service-to-service communication and from perspective of things that are available, including reliability component, including security component, and including observability component. All right, so it's time to jump into some demo. And the demo today, we will have a distributed system, microservices system, and e-commerce system as well. This is what you see here. It's called Online Boutique, and the system that you can go and buy some stuff. For example, if I'm interested in buying salt and pepper shakers, I can put multiple items and add this to cart. After that, I can do either continue shopping or I can do checkout. With the checkout, this is my address, this is my credit card that I'm using. And after that, when I can place the order, my order will be sent to warehouse for fulfillment, and I'll continue to work. So if you think about this, it can be one monolithic application, but actually this is a system where the multiple components are playing nicely together. So first of all, if you see here, there's a currency, I can switch different currency and my system will immediately will display all things in the current currency. For example, here I want to use Japan yen. It will show me immediately in Japan yen, and it can show me in USD and so far and so on. So this particular thing is actually calling external service that provides information about exchange rate. Now, when I want to go here and say add to cart, it will be handled by another service that will be handling the persistence of the cart. Address lookup and all these things also handled by another service. And when I click place order, it will simply send it to this. And the way how it works, this application is deployed using service mesh and exposed to outside world using Quant Gateway. So let's take a look what we can have here in this application. So personally, I didn't write this application, and I thought it would be a good example of what is possible to do with the system where you don't have access to the code. So in this case, this is the Google Cloud Platform microservices boutique system that all the components of the system is actually multiple microservices that are communicating to each other through gRPC. And all these things, there's a front end, there's a mail service, there's currency service, checkout service, advertisement service, and so far and so on. So I decided to take this and implement this with service mesh. So the way how it works, let's start with very beginning. My service mesh control plane already deployed inside my cluster. I'm using Kong Mesh, which is distribution of Kuma Mesh, just simply because it was handy for me to use. What I can see here from the day one, there's a default mesh is created for me. So all the things that I can see here. it already have a 12 data plane proxies. Let's take a look what do we have here. So we do have advertisement service, we have a card service, checkout service, and all these services are already part of the mesh. The way how it works, let's take a look how it works. If I go to my boutique namespace, this is where my applications are deployed. So all these services are here. So if I will show you definition for this, there would be very interesting annotation called Kuma IO sidecar injection enable. So what does it mean? If I go to any service, for example, this ad service, and I will see that this application will include two components. This is actually my application code. This is stuff that I will be running. And there's two things. There's a sidecar and init container. So sidecar container will be handling all the communication for the service. And as you can see here, it's one of the data proxies, data plane proxies here. So every service will have its own data plane, and this is what we see here when we open mesh list here. So when I go to overview of the mesh, you see already 17 data plane proxies. Some of the things also included from, for example, Prometheus. I do have a Grafana here. So not only my application will be part of this mesh, but also I can see how communication between external services also handled. I can show you this in a few seconds. The Kuma is designed to be developer friendly and provide some of the developer oriented insights for the system. So when the first time you run this default service without doing anything, you will see this very nice tip that allows you to see how we can improve your service. So before we jump in here, I can show you one quick thing before we enable all these kind of things. I do have Grafana and Prometheus deployed in my Kubernetes cluster, so I can start seeing some of the dashboards. Kuma provides the dashboards that allow you to observe things. So let's take a look on the control plane. And the control plane, this is our process that will be responsible for propagating this configuration. We can see this control plane is up and running. It's alive, and traffic is steady. So now we will be able to see some other things around mesh. So if I want to see, for example, service-to-service communication, I don't want to save any changes from the previous dashboard. I see no data because by default, we're not capturing any data between the systems. Communication between the components are, continue to be, but those things are not up and running yet. So what I need to do here is to enable those communication bits. And it shows what kind of components you need to enable, link to documentation. We're interested in a couple of things. We're interested to enable observability so we can see communication between those source systems. Let's take a look how we can enable this. And I already have my mesh configuration, and specifically, we're going to be looking at what we call it, if we go in here, we're going into traffic traces. So in this case, that's the policy that we can create, and these traffic traces will be able to capture communication between the services. So let's enable this. Have a traffic trace, and when you install Kuma in your Kubernetes cluster, it also installs a bunch of different custom resource definitions. One of the things here that you can see, it has this definition called mesh, and all the components that we will be configuring today, traffic trace, traffic log, all these things have a custom resource definition that allow you to focus on specific area rather than having dealing with some sort of like a config maps that would be more or less generic. Now, we can say that traffic traces all communication between all the services. Each service will be annotated with Kuma service. Let me show you. So this microservice demo, and I have a Kubernetes manifest. So it has annotations, what kind of protocol it serves, and this service will be served by Kuma Mesh. There's only one annotation that will tell Kuma what ports to listen. So since this particular service exposes port 9555, we will be listening this and report this to Kuma as well. So when I go here, I can say that every service, to communicate into every service, all the data will go to Jaeger collection. I already have a Jaeger deployed. If I go here and show you data sources, I do have a Jaeger deployed for capturing traces. I have a Loki deployed for capturing logs from those systems, and the Prometheus also deployed. Kuma itself, data plane, expose API that allows you to plug it directly to your Grafana. So information about service to service communication and data plane can be retrieved from here, from using the Kuma as a data source, as API data source. Now, another thing that we also enable is logging. So we need to know, in order to kind of make sense of the traces, we need to also capture logs from the system. So we need to say like communication from one source to another also will be captured through this, all the traffic will be captured by this policy. For tracing, we do have a collector configured, and for metrics, we're going to be using Prometheus collector. And for logging, we also will be using Loki collector. There's also ability to expose this to, there's some other collector that allows you connect this to, for example, Elasticsearch. Another thing that we will be enable is immediate communication between the systems. Those, what we called a MTLS between components. One of the things that you can see here in Kuma UI when you go into our view, you will get a, so enabling MTLS. So when I go in here, just click Kubernetes apply. So, and now my mesh was updated. We enabled traffic permissions for everything to everything, and we enabled encryption between the systems. So when I go ahead here and refresh screen, we'll see that all these things now enabled. We have observability is enabled, logging, tracing, everything is enabled. So we will be able to go into my Grafana, for example, and let's see what do we have here from perspective of observability. We're going here, I'm going home, and we're going to service communication. And now what we can do here, we can say we have a front end and goes into, say, payment service. And now when I go here and I will start doing this, my thing, that's what happened. So what just happened, I enabled a MTLS between my elements of this mesh, but my gateway that serves the proxy, the outside world, this stuff was not configured. So I don't have like the pod that will be route the traffic, the ingress pod now has a problems, right? So because it cannot communicate this, and specifically if I will go in logs and say, go to conk and go into my proxy. So it will set like I will not be able to go there. We're getting the error because we cannot reach upstream servers. So upstream prematurely closed connection. So what does it mean? So how we can fix that? In this case, our gateway doesn't have access to our mesh because our gateway is not the part of the mesh. How I can know that? In the UI, I can go and see here. There's a few types of data plane proxy. Standard data plane proxy that allows communication between particular service, and there's a gateway data plane proxy. So what I need to do is I need to also enable this and make my gateway, make my proxy server also part of this data plane. And the Kuma UI provides the ways how I can do this and gives me, so we're gonna do this namespace. We have a namespace called conk, and we're gonna do next. So it will generate us command that I need to modify. So I need to copy this command, go to my Kubernetes cluster and run this command. So what we'll do for namespace conk, this is where I am running my gateway. I also need to do sidecar injection, and also I need to mention that this guy needs to join this mesh. So what we'll do, we will bounce the conk pods. We also will, let's take a look what's gonna happen here. So this is the init container. Now my conk pod will get also sidecars here. So those sidecars will be injected as we speak right now. So we see the old pod is terminating, new one is starting up. Now it's created. We're going in through this crash loop back off a few more seconds, and we will get back to ready state. So we deploy the sidecar, meaning that all the policy around MTLS also will be applied to this component, to this system. And now looks like it's up and running. So let's see if I will go into mesh and there you see this gateway. And now I see there's a gateway proxies here. So gateway data plane. now my gateway data proxy has a communication between my service mesh, because now data plane established this MTLS connection between gateway data plane and my mesh data plane. And now what I can see, if I will go and refresh, my application is back to business. Now I'm back into doing my stuff. Let me do it smaller, so I can go sunglasses, I can add to cart, and I can do a place order and continue shopping. So I will be able to see all these things in my, for the last communications. Let's see, we're gonna do front end to advertisement service. Yes. So yeah, we do have the communication still up. But next important thing that I will be able to see is how my application topology looks like. And here's our, what we call a service map that allows us to see what is going on with this application. So this is Kong proxy. The traffic goes in, it goes into front-end service. So front-end service that actually serves all these things, all the requests, and makes it, routable. Let's generate a little bit more traffic to this system. So we will make sure that this communications actually works. Just quick refresh. Last 5 minutes. No, it doesn't want me to show. Maybe it requires some more data to collect. But essentially, from this front-end boutique service, we will be able to see how we can go in checkout, how we can go into cart service, how we can go to advertisement service. So once again, let me quickly summarize what you just saw here. So I took the existing application that's already available as containers inside this Google microservices demo. I installed them into my mesh in my Kubernetes cluster. Now those applications are running inside mesh. I enable MTLS communication between all the components. Now each and every application will have its own MTLS certificate that was released and that was generated by built-in certificate authority that is a part of control plane. My gateway also now is part of this overall architecture. So you can mix and match different. You can bring different components into this mesh. Not only your application, whatever you can put in the container, you will be able to join in the mesh. And now my Kong gateway communicate to the system, to these applications through MTLS. I also enabled by default some of the traffic permit routes, so every service can talk to each service. But I can be more explicit. Let us know in the comments, or let us know in the Q&A section if you're interested to learn more about those policies in the future, and we'll definitely get back to talk about those. And yeah, that's the nice with this nice UI, we can immediately understand what we're running here, what kind of how we're collecting. Let me show you quickly how we can see logs here that allows you to speed up your root cause analysis. For example, if I will go to my data sources and I will select something like, let's go explore. I can go explore and I will select Jaeger. So I'll just do search from the service front end to checkout, and we can do all the things. So one of the traces that come from front end service to checkout service will have this kind of I'm calling from front end to checkout, and I will be able to retrieve the service from the system. That I will be able to retrieve logs and see what is going on there. We see there was a call over HTTP2, which is gRPC, and all these logs from the from checkout service based on this particular trace. So that's pretty neat, and you will be able to do more things with this. So that's pretty much it for today. Don't forget, let us know how you like this or what you want to learn more in future. And with this, my name is Viktor Gamov, and as always, have a nice day.